First, fill the double styrofoam cup with 100 milliliters of DI water. Record the temperature of the water. The temperature of the water is 21.0 degrees Celsius. Place one magnetic stir bar into the styrofoam cups. Add 15.101 grams of sodium acetate into the DI water. Place the lid with the thermometer in the hole on top firmly onto the cups. Turn on the stirrer and allow to stir for 1 minute until the temperature remains constant. Now we will observe the changes in temperature. The temperature is now constant at 12.0 degrees Celsius. Now, dispose of the waste properly and clean the station.
Two possible sources of error for this experiment include the magnetic stirrer being turned off before the reaction was complete, and the solution gaining heat from the surrounding environment before the final measurement was taken for temperature of water. The first error works by raising the final temperature of the water, as this is an endothermic reaction that draws heat from the water to work. If the reaction was not allowed to complete itself, less heat would be drawn from the water, and it would result in a raised final temperature of the water. When calculating change in temperature by initial temperature minus raised final temperature, you get a lowered change in temperature for the water. Then using the equation mass times specific heat times change in temperature equals energy, the lowered change in temperature results in a lowered energy. The lowered energy, when set over moles to calculate heat content, results in a lowered heat content, as energy is part of the numerator. The second error works in a similar way. As the endothermic reaction completes itself, it draws heat from the water, which cools the water significantly cooler than the surrounding environment. As heat flows from the warmer area to the cooler area, it is possible that heat from the surrounding flowed into the water in between the time when the reaction was completed and the final temperature was taken. This would result in a raised final temperature. Once again, using initial temperature minus final temperature, the raised final temperature results in a lowered change in temperature. Then, once again, using Q equals MC change in temperature, The lowered change in temperature results in a lowered Q, which when placed in energy over moles to determine heat content, the lowered energy results in a lowered heat content once again.